This is the video that should be covering a lot of what we talked about with this particular worksheet. It's not the best lighting in here, but I hope you can still more or less see what I'm trying to show. This and this are both glucose. Carbohydrate, how do I know? Carbon, hydrogen, oxygen. Carbohydrates have carbon, hydrogen, oxygen pretty much exclusively, except for chitin, which might have one nitrogen group coming off of it. But we still see a ring, carbon, 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 oxygen. That's pretty typical for the sugars, also called saccharides, also called carbohydrates. Now this one did not copy as well as I had hoped, but we have these lines where you see these angles. It's understood that there's a carbon. This is what organic chemists do, so they don't have to write all the carbons. Remembering that organic molecules have carbon and hydrogen, so it's pretty much understood when we have carbons and hydrogens in any organic molecule. Number one, I'm looking for a repeat in units. In this case, I can see a 5-carbon sugar and a phosphate group. The phosphate group gives it away. This is a nucleotide. Here's 1. Here's 2. Whoops. Here's 2. And here's 3. I can tell because the phosphate is repeating each time. So these are 3 phosphates. I know it has to be a nucleic acid. Because I have this repeat, I know that it's not a monomer, because one of these would be a monomer. It's not a dimer, because there's not 2 of them. This is a polymer. As I said, the elements are going to be carbon, hydrogen, nitrogen or oxygen, nitrogen, and phosphorus. Carbon, hydrogen, nitrogen, oxygen, phosphorus. Nothing else in that particular case. Because of these charges, which are a little bit hard to see, and because of the OH and the NH2, because these are all very electronegative, the oxygens are very electronegative, the nitrogens are very electronegative, the phosphorus, thanks to these oxygens being around it, carries a charge. As a result, this is definitely very hydrophilic because it has nitrogen, hydrogen bonds, oxygen, hydrogen bonds, and a charged phosphate group. Charges are something that water likes. Water likes to mix with them. Therefore, it is hydrophilic. Next page is a little bit hard to see. Again, it didn't print quite as well as I would have hoped. But here we can see carbons, understood to be around here. Hydrogens, oxygens, carbohydrate. There's one of them. Here's another one. Here's another one. They were linked by dehydration synthesis. This is a carbohydrate. This one again, 1, 2, 3, the repeating units. This is a polymer. It contains the elements carbon, hydrogen, oxygen. All of these OHs, oxygen's very electronegative. Oxygen pulls on those electrons more, making hydrogen partly positive, oxygen partly negative. We've seen this over and over where I have a partly plus on a hydrogen and a partly minus on an oxygen. Therefore, and that's that delta letter we've seen before, this is hydrophilic. This particular carbohydrate is called cellulose. It's a polysaccharide. Polysaccharide, these are monosaccharides. Put together, it's a polysaccharide. Saccharide is another word for sugar, basically. All of the sugars end in ose. This is a complex carbohydrate. It doesn't dissolve. This is wood, this is paper. They're both made of cellulose. It doesn't dissolve in water because these are long chains and there's cross links. But water is definitely attracted to cellulose. Water is attracted to paper. That's how paper towels work, for example. So water is definitely attracted to cellulose, and it is hydrophobic because it has OH bonds, polar covalent bonds, just like water, and therefore it is hydrophilic. Next molecule. This is definitely, with this long carbon and hydrogen chain, definitely something nonpolar. The real principal molecule we see with a large nonpolar component are the lipids. So this is a lipid. This particular lipid, we would say it is a monomer, because I don't see the same thing repeated. If this were connected to something else in the same pattern, then that would obviously be a polymer. But this is definitely a monomer. It contains carbon, I can see, hydrogen, I can see, and oxygen. Because of this long carbon-hydrogen chain, carbon and hydrogens are nonpolar, because carbon and hydrogen have very similar electronegativities. Therefore, this one is hydrophobic because it has many carbon-hydrogen bonds. Now, this part is polar. It's a fatty acid. This part is polar. You see a carbon double bonded to an oxygen. This has a partly minus charge on it. This has a partly minus charge. Whoops. The oxygen has a partly minus charge, while the hydrogen has a partly plus charge. However, because of this long nonpolar chain, that overwhelms any small polarity that this molecule might have. Next one, we see another repeat of saccharides. This is another polysaccharide. These are glucose, one of the simple sugars stuck together again and again and again and again. This is one called amylose, but this is a carbohydrate. It's called amylose. It's another component of starch. It's a polymer because I see 1, 2, 3, 4, 5 different monomers there. This would more correctly be called a polysaccharide. It contains the elements carbon, hydrogen, oxygen. It is hydrophilic because of all of those the OH bonds, which are polar covalent. All the time we see oxygens with hydrogens, those are going to be polar covalent bonds. Nitrogens with hydrogens, also polar covalent. Carbons with hydrogens, non-polar covalent. Next page. See if I can zoom in a little bit. Not going to be successful with that. I'm going to try to make it a little bit brighter so this is easier to see. That's about the best I'm afraid I'll be able to make it. But if you have the paper in front of you, it should be fine. What I see is a repeat: nitrogen, carbon bonded to a hydrogen, carbon double bonded to an oxygen. Nitrogen bonded to a hydrogen, carbon double bonded to a hydrogen, carbon bonded to a hydrogen, carbon double bonded to an oxygen. This is the repeat. I have the same thing multiple times. 1, 2, 3, 4. It has nitrogen, carbon, oxygen, and hydrogen. Chances are we're dealing with an amino acid. Because of that, this would be the amine side. This would be the acid side. Now this is 4 of these units put together. If you remember, amino acids also have these subgroups sticking off, which really determine everything else about the protein. This particular amino acid also has sulfur in it. So this is a protein. I know because of what it contains. A protein is also called a polypeptide. This particular one is a polymer. It contains the elements carbon, hydrogen, oxygen, nitrogen, and in this particular case also has sulfur. Now, in this particular case, this group would be hydrophobic. This area would be hydrophilic. Hydrophilic, but also hydrophobic. Hydrophobic, more or less not very polar. This one, because of the OH, it is actually more of a polar molecule. But this is both hydrophobic and hydrophilic. This is why proteins are able to do so many things, because they can have parts that are hydrophobic and parts that are hydrophilic. And that means that the protein, as we've done, the protein takes on certain shapes because of those interactions. So it has, we can say, polar, covalent, nitrogen, hydrogen, and oxygen-hydrogen bonds, as well as carbon-hydrogen nonpolar bonds. This is why proteins are so interesting. Next one, I see that ring. I know that there are carbons here. This is a carb because of the carbons. Carbohydrogen. And then the 8 actually is the indication we also have oxygens. This particular carbohydrate is called sucrose. Sucrose is table sugar. There's the very sweet fructose, and then there's the not so sweet glucose, both stuck together in this particular dimer. Dimer because there's 2 units stuck together. It contains the elements carbon, hydrogen, oxygen, O bonded to H, O bonded to H, O bonded to H, O bonded to H. There's an O here, there's an O there. This is a hydrophilic molecule because it has many oxygens bonded to hydrogens, many polar covalent bonds. Next one, long chains of carbon and hydrogens. I think what came off here, what didn't copy very well were carbons here and hydrogens. Very, very nonpolar. If you remember, this is a saturated fatty acid that was the monomer. This is also a saturated, which means that all of the carbons have hydrogens connected. At least if one carbon is connected to another carbon, there's 2 hydrogens, then another carbon, 2 hydrogens, another carbon, 2 hydrogens. There are no double bonds. When you remove some hydrogens, you make what's called an unsaturated fatty acid, because it doesn't have all the hydrogen it possibly could. This bond could be broken. I could put a hydrogen here, a hydrogen here. But since they're not there, we call it an unsaturated fatty acid. In general, unsaturated fatty acids are liquids because these chains don't line up so well together. So yeah, they're kind of sticky because of hydrophobic interactions, but they're not as much as the saturated, which stick together fairly nicely and become a solid at room temperature. This is your butter, this is your lard, this would be your canola oil or your olive oil, something that's unsaturated. This overall, though, is a lipid. It's 3 fatty acids connected to a glycerol. So the 3 is triglyceride. Whoops. Let me write that a little bit nicer. Triglyceride. This one is a polymer because it has 3 units stuck together to the glycerol. Most lipids contain the carbon, hydrogen, oxygen. You may get in a situation where there's a phosphate group at the end. That's a phospholipid. What's going to be telling me that it's a lipid still? Those long carbon chains, carbon and hydrogen chains. This part is very nonpolar. In a phospholipid, the phosphate would be polar. These are polar also, the carbons and the oxygens, but they're connected to carbons and hydrogens. In general, this is a pretty nonpolar compound. So we'll say this is hydrophobic because it has many carbon-hydrogen nonpolar bonds. Okay. We have 3 more. Looking here, carbon, oxygen, hydrogen, nitrogen. Generally, in that case, one side looks like ammonia. We call that amino. This is actually an acid because these 2 oxygens pull so hard on electrons, this hydrogen can pop off, losing its electron. So this is an amino acid. We can also call an amino acid a peptide. When you join one amino acid to another through dehydration synthesis, we call that a peptide bond. This particular case is it is a monomer. It contains carbon, hydrogen, oxygen, nitrogen. This particular amino acid does not have any sulfur in it. This does have a hydrophobic part, all of these carbons and hydrogens, but it also has a hydrophilic part. The nitrogen and the oxygen give it some polarity. It's hydrophobic and hydrophilic because it contains polar covalent. Remember, covalent means sharing electrons. Polar covalent means one shares there's not as equal sharing, so the nitrogen or the oxygen holds on to the electrons more. It contains polar covalent nitrogen, hydrogen, and oxygen-hydrogen bonds. Whoa. As well as carbon-hydrogen nonpolar covalent bonds. Just for the record, that particular amino acid is a hydrophobic component when this is joined into a larger polypeptide. Here we have one unit. I don't see a repeat anywhere. I see a sugar, I see a nitrogenous base, nitrogen-containing base, and I see a phosphate. So this is a nucleotide, the basic building block of a nucleic acid. This particular case is a monomer, contains the elements carbon, hydrogen, oxygen, nitrogen, phosphorus, just like our previous nucleic acid that we saw. Because of all these nitrogens and oxygens bonded to hydrogens or nitrogens within rings, and a phosphate that has a charge on it, this is hydrophilic. It has, we'll say it has nitrogen-hydrogen bonds, oxygen-hydrogen bonds, and a charged phosphate group. And finally, last one, this is the same. I see this up here. So already I can tell nitrogen with 2 hydrogens, carbon double bonded to oxygen, OH. Already I can see that this is some sort of a amino acid. I also see that there's a repeat in that I've told you before, nitrogen to hydrogen with a carbon double bonded to an oxygen. So it's nitrogen, carbon double bonded to oxygen. That's one amino acid. Nitrogen, carbon double bonded to oxygen. That's another amino acid. So this is a peptide. Would be working towards a protein. 2 amino acids joined is not exactly a protein, though. It's just not big enough to really have any of a protein's functions. Proteins make structural parts of an organism. Proteins are enzymes. Proteins are also something called antibodies, which we'll talk about later on. This 2 amino acid molecule is not enough to make any sort of a protein. This is a dimer. Contains the elements carbon, hydrogen, oxygen, nitrogen. It's hydrophilic, and also here we have some hydrophobic. Hydrophilic and hydrophobic because it has polar, covalent nitrogen-hydrogen and oxygen-hydrogen bonds, as well as nonpolar covalent carbon-hydrogen bonds. And with that, we have completed this worksheet. You will see things very similar to this on the test, so please be prepared. Thank you for watching.